If you've ever wondered what makes your phone charger, TV, or even your car's electronics tick, you've probably encountered the word diode. I remember the first time I cracked open an old radio and saw those tiny, cylindrical components. I had no idea what they did, but I knew they were important. Today, I want to walk you through what a diode is, how a diode works, and why it's such a fundamental building block in electronics. A diode is a two-terminal electronic component that allows current to flow in only one direction. Essential for converting AC to DC, protecting circuits, and enabling modern electronics. The key to its function is the p-n junction. Diodes are found in chargers, TVs, cars, and countless devices. Electronics, as we know it, really began with vacuum tubes. Back in 1904, John Fleming invented the first diode, which was actually a vacuum tube. This early diode had two main parts: a heated cathode, which emitted electrons, and a plate, anode, that was positively charged. When the cathode was heated, it released electrons that were attracted to the plate, allowing current to flow. If the plate's voltage was reversed, the current stopped. This simple one-way behavior is the core of what a diode does. It lets current flow in one direction and blocks it in the other. Fast forward to today, and most diodes are made from semiconductors like silicon or germanium. At its heart, a diode is a two-terminal device with an anode, positive side, and a cathode, negative side. The magic happens at the p-n junction, where p-type and n-type semiconductor materials meet. Here's a quick table to break down the basic structure. Anode is a positive terminal. Cathode is a negative terminal. P-type has holes, missing electrons. N-type has extra electrons. P-n junction, the boundary where magic happens. The core function of a diode is to act as a one-way gate for electric current. When you apply a positive voltage to the anode relative to the cathode, the diode is forward biased and allows current to flow. If you reverse the voltage, the diode is reverse biased and blocks current. Let's break it down. Forward bias. The anode is more positive than the cathode. The p-n junction's barrier is overcome and current flows. Reverse bias. The cathode is more positive. The barrier at the p-n junction gets stronger and current is blocked. This behavior is called rectification, and it's the reason diodes are used to convert AC, alternating current, to DC, direct current. When p-type and n-type materials are joined, electrons from the inside fill holes on the p side, creating a depletion region at the junction. This region acts as an insulator, preventing current from flowing unless enough voltage is applied in the forward direction. In forward bias, the depletion region shrinks and current flows. In reverse bias, the depletion region widens and current is blocked. This simple mechanism is what makes a diode so effective at controlling current direction. Diodes are everywhere. Here are just a few of their key uses. Rectifiers, converting AC to DC in power supplies. Circuit protection, preventing voltage spikes from damaging sensitive components. Signal demodulation, extracting audio from radio signals. Logic gates, forming the basis of digital circuits. You'll also find specialized diodes like Zener diodes for voltage regulation, Schottky diodes for fast switching, and light-emitting diodes, LEDs. Let's look at a few common types of diodes and what they do. Standard p-n diode. Main function is one-way current flow. Typical use case is power rectification. Zener diode. Main function is for voltage regulation, typical used in power supplies. Schottky diode. Its main function is fast switching and low voltage drop, high-speed circuits. LED diode. Emits light when current flows, used in displays, indicators. Photodiode. Generates current when exposed to light, used in light sensors. Ever wondered how your phone charger turns wall power into something your phone can use? Inside, you'll find a bridge rectifier made of 4 diodes. These diodes convert the AC from your wall outlet into DC, which your phone's battery needs. Without diodes, this conversion wouldn't be possible. If you're looking at a circuit board, diodes are usually marked with a stripe on one end, the cathode. The symbol for a diode in a schematic looks like an arrow pointing toward a line. The arrow shows the direction of allowed current flow, anode to cathode. The line represents the barrier that blocks current in the reverse direction. Here are some important properties to know. Forward voltage drop. The minimum voltage needed for the diode to conduct, about 0.7 V for silicon, 0.3 V for germanium. Reverse breakdown voltage. The voltage at which the diode will start to conduct in reverse, usually much higher than the forward voltage. Current rating. The maximum current the diode can safely handle. You'll find diodes in power adapters and chargers, radios and TVs, solar panels as blocking diodes, LED lighting, car alternators. The keyword diode pops up in so many places because it's truly a foundational component in electronics. Understanding what a diode is and how a diode works opens the door to grasping much of modern electronics. Whether you're tinkering with a DIY project or just curious about what's inside your gadgets, knowing the basics of diodes gives you a solid foundation. Next time you see that tiny component with a stripe, you'll know it's quietly making sure electricity flows the right way. If you're interested in learning more, check out the video above and try spotting diodes in your own electronics. The world of electronics is full of these unsung heroes, and now you know exactly what makes them tick.